Good morning, everyone. Today we're going to explore one of the most common and dangerous cybersecurity threats in web applications, SQL injection or SQLi. We'll cover what it is, the different types of attack, their impacts on organizations, and most importantly, how we can prevent them. So what is SQL injection is? It is a type of attack where malicious SQL code is inserted into an application's input fields. These fields could be anything from a login form to a search bar. Once the malicious input is executed, the attacker can manipulate the SQL query to access or alter sensitive data, bypass authentication, or even compromise the system. So why it is important? Despite decades of awareness, SQLis remain one of the top web security risks. High-profile breaches, such as the ones that affected major organizations in the past, have shown the global impact of this vulnerability. Next part shows the mechanism of a typical SQLi attack. So let's walk through how it works. As you can see in the diagram, there are basically 3 steps to form the attack process. In the first step, an attacker sends the malicious HTTP request to the web application. Then, they can create the SQL statement and submit that SQL statement to the backend database. So let's take a very basic example here. As you can see in the figure 1, attacker can input admin in the username field and then input a malicious data like AAA single quote or 1 in single quote exactly like demonstrated in the figure. And then the query will become select star from users where username equal admins and password equal AAA or 1. And this SQL statement leads to a very serious result that authentication bypass due to the always true condition 1 and hacker might get access to all usernames and passwords in the database. There are several types of SQLi attacks, including in-band, blind, and out-of-band SQLi, as illustrated in diagram 2. So let's figure out what they are. In-band SQLi happens when the attacker uses the same channel to both send malicious input and receive data back from the database. Regarding the error-based SQLi, this technique relies on database error messages to gather valuable information about the structure of the database. For example, when an attacker enters an invalid query, the database might return an error like this: SQL error. You have an error in your SQL syntax. Check the manual that corresponds to your MySQL server version for the right syntax to use near at line 1. This error can give the attacker insights into how the database is structured and help them refine the attack. Regarding union-based SQLi, in union-based SQLi, the attacker used the union operator to combine the results of multiple select queries. This lets them pull data from different tables and access unauthorized information. For example, select name description from product where ID equal 1, union selects username, password from users. Here, the attacker could potentially access both product details and sensitive user information like usernames and passwords just by using the union operator to merge the results. Next, in blind SQL injection, the attacker can directly see the data returned by the query. Instead, they infer information based on how the application responds. The attacker might send different inputs and observe if the application behaves differently. If it behaves one way, they know the injected condition was true. Otherwise, they know it was false. Example of a Boolean-based blind SQLi. Imagine that you have a login form. The attacker could inject a query like this: select star from user where username equals John or 1 and password equal 123456. This query always returns true because 1 is always true, and the attacker can bypass the authentication. The double dash at the end of the input comment out the rest of the query, essentially ignore the password check. The second type of blind SQLi, which is the time-based blind SQLi. In time-based blind SQLi, the attacker injects a query that causes a delay in system response, allowing them to infer whether a condition is true or false based on how long the server takes to respond. If the query triggers a delay, the attacker knows the condition was met. For example, the SQL statement can be select case when 1 equals 1, then PG slip 10, else PG slip 0 and. This SQL query asks the database to pause for 10 seconds if the condition is true. If the attacker gets a delay in response, they know the condition is true. It's a way to gain information even without seeing the data directly. The last one is out-of-band SQL injection. So it is a more sophisticated method. Instead of retrieving data through the same communication channel, the attacker uses a separate channel, such as DNS or HTTP requests, to exfiltrate the data. This type of attack is often harder to detect because the attacker isn't pulling the data directly from the application. They're sending it to a server that they controlled. For example, the query can be select star from users, where users equal admin and 1 equal 1. Select load 5 attacker.com file. In this case, the attacker might use load file function to request a file from their own server. This could trigger a DNS request or some other communication back to the attacker's machine, allowing them to steal sensitive information without the application ever showing it directly. So what about the impact of SQLi? SQLi attack can have serious consequences for businesses. The first one is financial impacts. SQLi can result in direct financial loss due to data breaches, regulatory fines, legal settlements, and ransomware attacks. In fact, the average cost of a data breach in 2024 has risen to 4.88 million, as you can see in Figure 2 reported by IBM. The next one is the reputation damage. A breach can lead to loss of customer trust and negative media coverage, severely impacting the company's reputation. Once trust is lost, the customer may take their business elsewhere. The last one, operational disruption. SQLi can cause system downtime, data loss, and operational outages. For large organizations, this can result in significant disruption to day-to-day business activity. So how do we defend against SQLi? The first one is prepare statements. By separating the SQL code from user data, prepare statements ensure that input is always treated as data, not executable code. The next one is store procedures. These predefine the SQL's queries, reduce the risk of SQLi by separating the query structure from user input. The third one is web application firewalls. It can detect and block malicious SQLi patterns before they reach the application, providing an additional layer of protection. And the last one is the proper error handling. It never exposes detailed database error messages to user. This helps prevent the attackers from gathering information about the database structure. So in conclusion, there are some key takeaways for the topics. Firstly, SQLi techniques. Attackers use evolving methods such as in-band, blind, and out-of-band SQLi, each with unique risk profile. Secondly, high impact. Financial losses, data breaches, and irreparable damage to brand reputation. Next, effective prevention, prepared statements, input validation, web application firewalls, proper error handling are crucial in protecting system. And finally, call to action. Don't wait for an attack to happen. Implement best practices now. Regular update security protocols to defend against emerging SQLi techniques. So this is the end of my presentation. Thank you for your time and attention today. I hope this presentation has provided you with valuable insights into SQL injection attacks, their impacts, and prevention strategies.